Hi, everyone. Thanks for showing up for your learning. Uh, some of the foundational skills that we're going to look at in this video are combining like terms and the distributive property. So combining like terms is making sure that we know how to add apples together with apples, oranges together with oranges, but no one's trying to make some kind of abhorrent apple-orange juice. That'd be gross. So in this case, we've got a case of we have in here some things that are like terms and things that aren't. I'm going to write down this expression in another order. Negative 7y squared, and then I go ahead and look for other y squareds, plus 3y squared. And then I'm going to write down my x cubeds, plus 6x cubed minus 4x cubed. And then I have minus 6 minus 2 minus 2. Now this is organized in such a way that I have all of my y squareds together, all of my x cubes together, and all of my constant terms, all of my numbers together. Now I can add these together. So in this case, this will be equal to, what I write on this line here is going to be equal to what was written over here. Minus 7y squared plus 3y squared will give me minus 4y squared. That's going to be how many of them I have. I had minus 7 of them, then I added 3, so that left me with minus 4. And then how about x cubeds? Well, I had 6x cubeds, and then someone took away 4 of them. So I will be left with 2x cubeds. And then I have minus 6 minus 2 minus 2. That would be minus 10. And that's done final answer. So let's input that. Minus 4y squared plus 2x cubed minus 10. And Delta Math likes that. You go through and you take a look. What did Delta Math do? They used a color coding system. You could absolutely put boxes around these things, use different colors to make sure that you can see the different like terms. What we do is we look at the variable and the exponent. They both have to match, and then that's a like term. We can put those together. Okay? And so they combine all those things, and then they get the same stuff, and we are done. All right. So that is combining like terms. Sometimes you will have examples like this, where I have some linear y's along with squared y's. These are not like terms. In this case, let's do it without writing out an extra thing. I have negative 2y squareds plus 2y squared plus 3y squared. So I'm going to end up with 3y squared. Negative 2 plus 2 is 0. Plus 3 gives me 3. Now let's count my linear y's. Negative 3y minus 7y, and that's all of them. So it looks like minus 10y. And then my constant terms, 5 minus 3. So that would be plus 2. Let's see if Delta Math likes it. Yeah, so this is collect like terms. We really want to be high level with this skill. This should be very fast for us to get to our results. That's going to make a lot of the processing that we do this year easier. Distributive property is where I'm going to be solving problems like this one, where I have 4 of this bracket, x plus 2x squared. Okay. When I do this, I notice I don't have like terms inside this bracket. I cannot simplify this at all. That can't simplify. But I can do this multiplication here. This is multiplication. So let's do that multiplication. We're going to do 4 times x and 4 times 2x squared. So 4 times x is just a number I don't know yet, and 4 times that number will be 4 times that number. This is the way we write it down. 4 x's is 4 times x, plus 4 times 2 times x squared. Let's write that down. 4 times 2 times x squared. Well, to evaluate that, doesn't matter what order I do it in. 4 times 2 gives me 8, and 8 times x squared is what I'm looking for. So the final answer here is 4x plus 8x squared. So with these types of problems, We just want to make sure that we get all of the terms and that we don't mix up and add together any like terms, any unlike terms. X's do not add together with x squareds, but we can write them in this way. So I'll submit that answer. I'll say yes. Hooray. Let's take a look at another one. Here, this one would be 5 times 1 would give me 5, and 5 times 4x would give me 20x. So this is the way I answer these types of questions. This is the way we do it. I made a mistake. 5 times 1 is 5. 5 times 4x. Oh, it says I'm right. Oh, yeah, I was looking. What is going on? And it showed me in slow motion how we do that. That's very cool. Okay, this one here, negative 6x squared minus 20x. Negative 6x squared minus 20x. And then you say, submit it, enter, hooray, and then watch it in slow motion. Oh, it's so beautiful. And it leads us to the correct answer. Oh, that's great. It's good to have these visualizations for it. What happens when we look at level 2? Here we have a monomial, a single term, multiplied by a trinomial. But it's the same thing. Let's write this one out and solve it. Here we go. If we're going to take this monomial, minus 2x, and multiply it by a trinomial, 3 terms, we're going to have to do 3 different multiplications. Negative 2x times 2x squared, negative 2x times 7x, and negative 2x times 8. So I'm going to write these out very carefully. First one looks like this. Negative 2x, this is going to be equal to multiplied by 2x squared plus negative 2x, maybe I'll put that in brackets to avoid a double sign there, multiplied by 7x. And then I'm going to have plus negative 2x multiplied by 8. So let's do these piece by piece. This is an elephant that we're going to eat 3 bites at a time. So here, negative 2x times 2 times x squared. There are 1, 2, 3 x's, so this will be x multiplied by itself 3 times. I multiply by x once, twice, 3 times. You see this is squared, so that's 2 times. So that's going to end up being 3 x's. And then, to find out the number, the coefficient, I take these two numbers and multiply them to give me minus 4. So it'll be minus 4x to the 3. And then next term here, negative 2 times 7 is negative 14. X times x is x squared. And then over here, negative 2 times 8 is minus 16. And x times itself once is x times itself once. Let's input that and see how we did. Minus 4x to the 3 minus 14x minus 16x. I forgot this one is x squared. There we go. Submit that answer. Enter. Hooray! Let's see. Oh, there's no slow motions in this one, but you can follow through. It shows you this, shows you the answer. It says distribute. So that's how we collect like terms and apply the distributive property to resolve these multiplications around fractions. Any questions, hit me up by email or find me in class. Bye for now, everyone.